It's Jo Karen Hudson. This video is on adding, subtracting, and multiplying polynomials. First of all, let's start with adding and subtracting polynomials. The first thing we want to do when we're adding or subtracting polynomials is to eliminate the parenthesis. And secondly, we want to combine the like terms, writing the terms in descending powers. So let's start with example 1. Add or subtract the polynomial as indicated. So the first thing we'll do is eliminate the parentheses. There's not anything out here to multiply times to distribute with the parentheses, so it's like distributing a 1, or we can simply take them off. 3x squared minus 6x plus 8. And there's nothing out here, out in the front of this one to multiply, so we can simply take the parentheses off. It's like distributing 1. And then we simply combine the like terms. So we want to put them in descending powers, so we want to start with the squared terms first. 3x squared plus 1x squared would be 4x squared. And then we'll go with the x terms. Negative 6x plus 3x would be negative 3x. And then we want to go with we want to add the numbers together. 8 plus 10. 8 plus 10 would be 18. Example 2. There's nothing out in front of the parenthesis to multiply, so it's like distributing a 1, or we can simply take the parenthesis off. 3x squared minus 6x plus 8. But there's a negative in front of this parenthesis, so it's like distributing a negative 1. So we'll distribute a negative 1 with all three of these terms. Negative 1 times x squared would be negative x squared. Negative 1 times 3x would be negative 3x. And negative 1 times 10 would be negative 10. And then we'll combine the like terms. First of all, 3x squared minus understood 1x squared would be 2x squared. And then we have negative 6x and negative 3x, which would be negative 9x. And then we have our numbers, our constants, 8, positive 8, and negative 10, which would be negative 2. Our third example, we're subtracting and adding binomials together in this case. Our first set of parentheses is like distributing a 1, or we can simply take the parentheses off. Negative 4x cubed plus 9x. Here we have a negative, so it's like distributing a negative 1 with those two. So we have negative 1 times x squared would be negative x squared. Negative 1 times 10 would be negative 10. And here we can simply take the parenthesis off because there's only a 1 to distribute, which keeps it the same. Now we're going to combine our like terms. We start with our x cubes first. We have negative 4x cubed and negative 5x cubed, which would give us negative 9x cubed. And then we'll go with our squared terms next. See, we only have one squared term, so we just write it down, minus x squared. And then we'll go with our x terms. We have 9x and 1x, which would give us 10x. And then we just have the one constant, so we'll finish it up by subtracting 10. Finding the perimeter of a rectangle. To find the perimeter of a rectangle, we can add all of the sides together. The perimeter is the distance all the way around, so we can add all of the sides together. We know if we have a rectangle and the length is 2x squared plus 5x plus 4, it's the same. Both lengths are the same and both widths are the same. Or we can use our formula for rectangles, which says the perimeter is equal to twice the length plus twice the width. And so the perimeter is twice the length, which is 2x squared plus 5x plus 4, plus twice the width, which is x plus 2, or we'll have the perimeter is equal to 4x squared, 2 times 5x would be 10x, 2 times 4 would be 8, 2 times x would be 2x, and 2 times 2 would be 4. So our perimeter would be 4x squared, 10x and 2x would be 12x, and 8 and 4 would be 12. Finding the distance around it. All right, let's review our product rule and our distributive property. The product rule, we've had this before. When we multiply 3x squared times 2x cubed, we're going to multiply the numbers together first. 3 times 2 would equal 6, and when I multiply x squared times x cubed, remember when we multiply like bases we add the exponents, so this would be 6x to the 5th. And our distributive property, we're going to distribute the negative 5 with both of these. Negative 5 times 4x cubed would be negative 20x cubed, and negative 5 times 9 would be negative 45. Okay, let's multiply and simplify the following polynomials. This first example uses the distributive property where we're just going to multiply negative 4 times both of those. Negative 4 times 3x would be negative 4 times 3y would be negative 12y, and negative 4 times positive 7 would be negative 28. Example 2, we have two binomials to multiply together, and when we multiply two binomials together, we use a property that's called FOIL. It's just like distributing twice. The first, the outer or the outside terms, the inner terms, and the last terms. FOIL. The first terms, here's the first terms, the first one in each set. These are the outside terms, the ones on the outside. These are the terms that are on the inside. And these are the last terms. So let me recopy it. 3p plus 5 times 3p minus 5. So when I multiply the first terms, the 3p times the 3p, I get 9p squared. The outside would be 3p times negative 5, which would be negative 15p. The insides would be 5 times 3p, which would be plus 15p. And the last would be 5 times negative 5, which would be negative 25. So when I combine the like terms, I'll have 9p squared. These two add up to 0 minus 25. Now that is a special case which we'll talk about in the next section. We'll talk about that some more in the next section. 7p plus 4 times 7p plus 4. We're going to do the first 7x plus 4 times 7x plus 4. We're going to do 7x times 7x, which is 49x squared. The outside would be 7x times 4, which would be 28x. The inside is 4 times 7x, which is another 28x. And the last would be the 4 times the 4, which would be plus 16. So we have 49x squared. When I add the 28x and the 28x, I get plus 56x plus 16. And that is another special case. We won't do all special cases. Let's go on to example 4. We're going to do first 4x times 3y. Well, now 4 times 3 makes 12, and x times y makes xy. The outside 4x times negative 8 would be negative 32x. The inside 5 times 3y would be plus 15y. And the last would be 5 times negative 8, which would be negative 40. And none of these will combine together, so this is our final answer on that problem. Example 5. Here I have a binomial times a trinomial, we can't use FOIL unless we have two binomials, but we use the same procedure where we multiply the first one times all three of them, and then we go back and multiply the last one times all three of them. So when we multiply the first one, we have 3t times 3t squared, which would be 9t cubed. And then we have 3t times 3t, which would be 9t squared. And then we have 3t times negative 1, which would be negative 3t. Then we're going to multiply the negative 2 times all three of them. First of all, negative 2 times 3t squared makes negative 6t squared, and the negative 2 times the 3t makes negative 6t, and the negative 2 times the negative 1 makes plus 2. So combining the like terms, there's only one cubed term. So I'm going to write it down, and then I have 8t squared minus 6t squared, which would be 3t squared. And then I have two t terms. Let's see, negative 3t minus 6t would be minus 9t plus 2. Example 6. We have a monomial times two binomials. And when this is the case, it's customary to multiply the binomials together first. Multiply the binomials together first. So we have 3y squared. When I multiply the first here, I'll have y times 3y, which would make 3y squared. And then when I multiply the outside, y times negative 5, I'll have negative 5y. And when I multiply the inside, I'll have 2 times 3y, which would be 6y. And when I multiply the last, let's see, these are the last, I have 2 times negative 5, which would be negative 10. So I have 3y squared, and when I combine the like terms in the middle there, I'll have negative 5y plus 6y would be plus 1y, or just plus y, minus 10. Now that I have multiplied the binomial pairs together, I'm going to multiply the monomial times all three of them. So I have 3y squared times 3y squared would be 9y to the fourth. Notice how I added the exponents. And then I have 3y squared times y, which would be plus 3y to the third. And then I have 3y squared times negative 10, which would be negative 30y squared. This concludes this video. This is Jo Karen Hudson. Thank you, and have a wonderful day.